Today we're going to be doing matrix multiplication. We've been working on the operations of the matrices, and we're going to kind of progress the multiplication here. We're going to talk about how to figure out if you can do multiplication, because just like the operations, there's going to be cases where we cannot actually do the operation there. We're going to talk about too then how to actually execute it. So the first thing I want to discuss here is matrix dimensions. You've learned about the matrix dimensions, and the dimensions are always the number of rows by the number of columns. So your first step today in all these problems is to figure out what the dimensions of each matrix are to start off with. So here's our first example. It says, what are the dimensions of the product A times B if, and they have the two matrices here. So this first one is matrix A. It goes in order of how it's pronounced there. And this is matrix B. And they want to know, if we were to multiply these two together, what would the resulting matrix be? Now, in your operations, they had to be the exact same dimensions in order for you to add or subtract them. That is no longer true for this. So they don't have to be the same. They have to have a similarity in them, though. So we're going to first figure out what the dimensions are. So in this one, since it's row by column, A has 1, 2, 3, 4 rows by 1, 2 columns. So this would be a 4 by 2 matrix, where B has 1, 2 rows by 3 columns, 1, 2, and 3. So you can clearly see they're not the exact same. So how we figure out if we can actually do the multiplication? We look at these two inside numbers here, and they have to be the exact same. So the number of columns from your first matrix has to be the exact same as the number of rows from your second matrix. All right, if they're not the same, then we cannot do multiplication. Now, the whole point of this question is to figure out what is the dimensions of our brand new matrix if we actually do the matrix multiplication. All right, we're going to take the rows from matrix 1 and the columns from matrix 2 to make the new dimensions. All right, so if we multiply these together, it should result in a 4 by 3 matrix, because we are going to take the rows from the first one and the columns from your second one. All right, so we're going to have a kind of a bigger matrix here. So just to refresh, in order to do multiplication, the number of the number of columns from the first one has to be the same as the number of rows. So I'll write that out for you guys here. In order to perform matrix multiplication, the number of columns from the first matrix must be the same as the number of rows from the second matrix. All right, if that is not true, then you say not possible or undefined. You cannot complete that multiplication. So what we're going to do now here is we're actually going to do the multiplication. We're going to do A times B and get that resulting product matrix of a 4 by 3 matrix. This is kind of a lengthier process, I'm not going to lie. It's going to take a while, so I'm going to show you kind of how to structure it and what I'm kind of looking for here. So real quick, we know we're going to have a 4 by 3 matrix, so I'm going to go and make that, make that matrix. All right, 1, 2, 3, 4. All right, I'm make it a little bit big here. Okay, so I'm going to have a 4 by 3 matrix, like I said. All right, what we do is we learn that when we do matrix multiplication, we're taking the rows from the first one and the columns from your second one. So that's what we're going to do. So to find this first entry here, right, row 1, column 1, we go from the first row of A and the first column of B, and we do the multiplication there. All right, so you see we have two sets of numbers there. So you take the first numbers in each of them and multiply them by each other. So I'm going to do 3 times 10 plus 9 times negative 5. All right, and that will give me my first row first column entry. We're going to repeat this process for the other columns in that row. So I do one row at a time. So I'm going to do that first row. Second column will give me my second entry. All right, so that one will be 3 times negative 3 plus 9 times 4. Finally, I'm going to do that first row, third column. That's going to get me my row 1, column 3 entry. That's going to be 3 times 2 plus 9 times 9. And we have completed that whole first row. We're going to repeat this process for all the other rows in column or in matrix A. All right, so we're going to do row 2, column 1. Row 2, column 1 will give me this entry right here. So that's negative 2 times 10 plus 4 times negative 5. We're going to do row 2, column 2. Negative 2 times negative 3 plus 4 times 4. And finally, we're going to do row 2, column 3. Row 2, column 3 will give me my last entry here. Negative 2 times times 2. Okay. Plus 4 times 9. And we've completed that row now. And we move on to the next. All right, we're going to do row 3, column 1. Row 3, column 1 will give me the third row, first column. So I'm going to do 6 times 10 plus negative 7 times negative 5. We're going to do row 3, column 2. 6 times negative 3 plus negative 7 times 4. And finally, row 3, column 3. 6 times 2 plus negative 7 times 9. All right, the final row here. Pause this video, see if you can do that last row by yourself. Once you have it, unpause it and check your answer with me. So for this last row here, you're doing fourth row, first column first. So I got 11 times 10 plus negative 1 times negative 5. I'm going to do that last row, second column. 11 times negative 3 plus negative 1 times 4. And finally, last row, last column here, 11 times 2 plus negative 1 times 9. All right, and we have completed the multiplication now. Now, the only issue here is it's a pretty ugly matrix. So what we're doing is we're actually going to go in our calculators and type in each of those entries to get the final number there. So I'm going to remake my matrix right down here. All right, so we're gonna do that first row first here. So you're gonna type in each of those things. So you're gonna type in that first entry right there. So I'd be typing in 3 times 10 plus 9 times negative 5 into my calculator, and you should get negative 15. I'm gonna type in 3 times negative 3 plus 9 times 4, and you should get 27. And then we're gonna do 3 times 2 plus 9 times 9 and get 87. We're going to repeat that process for all the other ones as well. So negative 2 times 10 plus 4 times negative 5 gives me negative 40. Negative 2 times negative 3 plus 4 times 4 is 22. And then negative 2 times 2 plus 4 times 9 is 32. The next row, 6 times 10 plus negative 7 times negative 5 would give me 95. 6 times negative 3 plus negative 7 times 4 would give me negative 46. And then 6 times 2 plus negative 7 times 9 gives me negative 51. And our final row here, 11 times 10 plus negative 1 times negative 5 is 115. 11 times negative 3 plus negative 1 times 4 is negative 37. And 11 times 2 plus negative 1 times 9 would give you 13. And that would be my final 4x3 matrix. Now, once you get better at multiplication, you can skip this step, all right, and go straight from here to here if you want. That's fine. I do recommend for the first couple times just writing all those steps out just so you learn the process, and it kind of gets in your head a little bit more. All right, let's do some more example problems. All right, in this problem here, it says find u times m. Now, this problem is all about showing you that the order matters. So whichever matrix you have first, that has to be the one you write out first. So if I do u times m, I'm going to rewrite these so they're in the correct order. So since u is first, I'm going to rewrite that one. times m in order to do matrix multiplication, you have to check the dimensions first. So I would say U, that looks like a 2 by 2 matrix, and M looks like a 3 by 2 matrix. Now again, we have to figure out if the actual matrix multiplication is possible. So you look at these two inside numbers here. Are they the same? No, they're not the same in this problem. So we are not able to do the multiplication. So we would say not possible. Okay, it's undefined. Okay, because in order to do multiplication, the number of columns from the first one has to match up the number of rows from your second one. So we'd say, nope, not possible. If we flip-flop the order, if we did m times u, then that would be possible. But since it tells us that you have to do it in a certain order, right, it would not be possible. The last type of problem you could see is going to be this, where I'm going to actually have the multiplication done for you. So we have our first matrix there times our second matrix, and we already have our product matrix. It says equals that product matrix. The catch here is you just solve for x and y. So what we're going to do is you're going to have to make some equations up here in order to solve for x and y. The best way to do this is you're going to learn by process of getting better and better. There's going to be some chances where we make the wrong equation, and that's okay. We'll bounce back from that. So let's solve for x first. All right, remember, from your first matrix, all right, from your first matrix right here, you take the rows. From your second matrix, all right, you take your columns. So I would say let's do our first row here if I'm solving for x, because that's where the x is. And I look over here, I'm thinking, which column has x? Well, to me, this column has the x. So I'm going to use that row and that column. If I do that multiplication there, I'm going to say 2x times 0 plus 1 times 3x. And that needs to equal something. So then you're going to go over here to your product matrix and figure out which of those entries goes with this. So if I did my first row and my first column, which entry over here is the first row, first column? Well, my first row, first column entry is negative 12. So this should equal negative 12. And I'm going to do the math from here and solve. 2x times 0 is just 0. 1 times 3x gives me 3x equals negative 12. I can divide both sides by 3. I get x is negative 4. All right, now we're going to solve for y. If I look over here, I see my y right here. And so that is in that second column. So I know I have to use the second column. All right, and we're going to figure out which row to use. So let's just try the first row here. First row, second column. So I'm going to do that multiplication. I've got 2x times 3 plus 1 times negative y equals. We have to figure out which entry from our product matrix corresponds to that. So if I do first row, second column, I have to go to your first row on your product one and the second column. That number is negative 29. Now the only catch here is you look at this equation, we have both x and y in this equation, but the good news is we already know what x is, so I'm going to substitute that in. Okay. 2 times negative 4 times 3 is negative 24 minus y equals negative 29. I'm going to add the 24 over and then divide by negative 1. I get y equals 5. You can't have the instances where maybe you choose the wrong row or column and it kind of backfires on you. So I want to show you an example of that. So in this one, we knew we were going to use the second column, but what if we had tried the bottom row, that second row there? What would happen? If I tried the second row, second column, I would get 2 times 3 plus 0 times negative y equals my second row, second column. That number would be second row, second column, 6. If I go and solve this, I get 2 times 3 is 6 plus 0 times negative y would just be 0 equals 6. And the issue here is our whole point was solving for y, and we just had that go away.